Testing. 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 Testing if this thing is repeating itself. Testing if this thing is repeating itself. Hi there. I see that somebody is watching. That is very exciting. You are my very first audience member ever. I hope you enjoy. So, today we are going to talk about landing on Mars and why that's really, really hard. And if you could say something in the live chat, that would be great, so I could see who you are and if I know you, because I might know you. That would be cool. So I hope you'll bear with me as I figure out the kinks of this very first live stream of Space Talk. So what I think you're seeing is a Ars Technica article about. Oh, actually, you're not seeing that. Now that's interesting. Let me see what I have to do to make that happen. Maybe if I push that button. There we go. I see. Okay. So now you should see on your left side an article about SpaceX and their changing of their plan to land on Mars with their Red Dragon capsule. Now, landing on Mars is really hard, and we have done it a number of times, but more often than not in history it has failed. So we're going to talk a little bit about how it's done and why, and what Elon Musk apparently thought he could do and why he may have changed his mind. So here we go. By the way, my name is Jeff Nasanov. I am a former NASA person. I worked on advanced mission concepts for several years, and now I have a startup company, and I like to talk about space. So let's take a look at this article. So really, the most important thing you can see in this article is what the initial plan for SpaceX was, which was landing this thing, the Dragon capsule, on Mars. But mostly I want to focus your attention here to these little things that look like rockets, because that's what they are, the rockets. So the idea was that he could land on Mars using those to slowly descend through the Mars atmosphere and land with rockets, basically. So there's a lot of text here. I can post the article if anyone is interested later, but that was basically the idea, and in a very oversimplified form. But it turns out that's extremely difficult, and so one of the things I would like to show you is the most recent major Mars landing and how that was done. So we're going to switch to this, and hopefully this will work. So what I've switched to is a YouTube video that shows how the Mars Science Laboratory rover landed a few years ago, about 5 years ago actually. And this is an awesome video, but what we've skipped is the part of the video of how we got to Mars in the first place. You know what? Since there's one person watching and just about 30 seconds, we can watch it. So, so this is the spacecraft leaving the Earth, and I believe you can hear this. If not, I'm going to check my settings while you're watching this. So that's the spacecraft approaching Mars, and you can see there that the solar panels and the back shell is what that's called, has come off. Actually, that's not the back shell, excuse me, I'm trying to do too many things at once. So as we approach the landing of the Mars Curiosity rover, you can see we're coming in pretty close to horizontal almost, and the rover is using its jets to actually keep itself heading straight in. There's a very strong heat shield there that's absorbing a lot of the energy coming from the entry. So when you enter let's pause it and talk about this actually for a minute. When you enter a planetary atmosphere, you're going extremely fast, and that speed heats up your spacecraft because you're passing through atmosphere, you're colliding with air, with some kind of atmosphere, and that causes tremendous heating. And what that also does is it slows your spacecraft down. It slows your spacecraft down from thousands of kilometers per hour to maybe the low thousands, or possibly even under 1,000, depending on a lot of different things. But it's an extremely sharp deceleration of your spacecraft. So we'll go on from here. So you can see that those attitude control jets are actually still firing to keep the spacecraft lined up so it doesn't start tumbling. So what you see here is these little guys here. Those are little ballast weights, so those are weights that are used during the cruise stage, that is going from Earth to Mars, to keep the spacecraft, to keep the mass balanced across across the axis of rotation, center of gravity, and otherwise to keep it rotating properly. So there's still just one person watching. That's cool. I'm glad you're here. So the next step, after a stage of deceleration caused by air friction, is the giant parachute. And it is a giant parachute. I believe it was the largest one ever used anywhere at the time. Maybe still is. So before I go on to the next step, there's something I want to call attention to, which is that we've now used two completely separate deceleration systems. And I'll admit I don't know exactly what all of the steps are in the Elon Musk SpaceX Red Dragon deceleration plan, but you can see we haven't seen any actual retro rockets yet. We haven't seen any of these. And we're going to talk more about why. So moving on, before we'll recap, we've had going through the atmosphere and giant parachute. So now you have something totally crazy and awesome, which is dropping. And here are the retro rockets. So here is the method of retro propulsion that we see in artist rendering form on the Ars Technica article. So that is what appears to have been the major change in Elon Musk's plan, is that it's no longer relying entirely on retro rockets, or it's at least reducing its reliance. So the key that we observed from the previous Mars landings is that the retro rockets work well at much lower altitudes. More specifically, they work well when they activate at lower velocities. So remember, by the time the retro rockets turn on, the thing has passed through the atmosphere. It's slowed down due to air resistance, and it's slowed down with the parachute. So the retro rockets are not active in the whole descent. And actually, the retro rockets are really only active in a very small part of the descent, and not even all the way down. Reason being that, as you can see here, the rover itself is lowered by cables. I'll pause it here just so you can see this just remarkable and ludicrous but effective system. The rover is actually ultimately lowered by ropes, cables, to make sure that the retro rockets don't kick up too much dust on the ground, which is what would happen if the rockets were used to descend all the way. So you can see that the sky crane, that's what that system is called, the sky crane is hovering, and so there'd be plenty of fuel if it was part of the plan to decelerate all the way down, but that wasn't part of the plan. So then the sky crane cuts the ropes and flies away. So that's how we landed on Mars about 5 years ago. And we can speculate about why, or what, first of all, we can think about what Elon Musk's plan was in the first place and why it may not be the plan anymore. It's important to remember that I'll leave this playing for a little while. It's important to remember that the systems that they're going to land with in the future are much heavier than this rover, but that opens a whole new area of systems, because NASA's never landed anything that big on Mars. So the question is, can SpaceX do it, and how? So I think we'll pause here. What we'll do next is look at a different Mars landing, which was the Spirit and Opportunity landing, which was 8 or 9 years earlier, and I believe that this is the video. This is okay. So yeah, this is the video. Let's see. So let's see if we can just watch the whole thing. Yeah, it gets to Mars pretty quickly. So if people are interested, we can do another video about launching these things. But for now, I wanted to talk about the actual landings. So we launched into space, big rocket. And we'll skip ahead to Mars. So we're left the Earth. See the rocket staging there. And we have separated and we're off to Mars. So, okay, we're going to accelerate. We can talk another time about why that happens. I can see that the video is a little choppy on the stream. I want to see if I can do anything about that in the future. Maybe I don't want to lower the resolution. Anyway, so you know what? We can actually skip through some of this. Yeah, actually, we can skip to this point. So, like before, there's a cruise stage that separates the rover, or rather the landing system. Again, it goes through the atmosphere, heats up. I love these clips from the control room. You know, my stream dashboard says 2 people are watching. I'm not sure if one of them is me. I'm okay with that. And that, luckily, it records them and puts them on my channel separately as videos anyway. So hopefully someone else will watch this. So we slowed down through the atmosphere. Now we have a parachute. Now this spacecraft is lighter than the Mars Curiosity rover. It's lower mass, so it's a different approach to land. But as you can see, it's no less creative than the later one that we watched earlier. So you can see there's the rover itself is down here, lowered way below the spacecraft and the parachute. And then we have inflation of a whole bunch of airbags. Again, a retro rocket system, also kept off the ground. And then this, again, amazing and insane thing of the rovers bouncing in a giant set of airbags down to the ground. And you know, you can watch this stuff, and I used to work with the people who designed this, and it's amazing that this is the best solution, but it was the best solution at the time to get the system on the ground. So you can see it in either of these missions, you didn't have retro rockets as the dominant form of deceleration. And you actually only had them during a short part of the descent. And there's the team waiting for the signal. And let's watch the thing unfolding, just because that's fun. So the airbags are deflating. But again, so the retro rockets are not a major part of the descent. Now, if you were to land 10 times the mass of the Curiosity rover, which was the previous video, maybe you could use retro rockets all the way. It doesn't seem like that's what's happening. That isn't what that seems to be the subject of the announcement from SpaceX. So now they're saying that, I'm going to stop this for now because that's the important part. Now they're saying that, let's see, they have a far better approach. Well, I can't wait to see what that is. So far what's been used on Mars is parachutes, giant balloons, retro rockets, and air resistance. So hard to imagine what the far better approach could be. Maybe it's a different staging of those things. I don't know. Oh, we have a third visitor. Hello. We've been talking about landing on Mars and what could be going on at SpaceX and why they may have changed their plan. So since we have another visitor, I'm going to kind of do a little summary because there's not that many people here. Oh, that was the beginning. Okay. So we're going to talk about how we land on Mars typically. I shouldn't say typically because it hasn't happened enough for it to be typical, but there's a certain set of parallels in all of the different landings that have been successful at least. So we're going to go back here and talk about how the Curiosity rover landed on Mars. So here it is coming through the atmosphere. Again, keeping in mind that interesting. So someone just left. I don't know who that was. Hopefully the person who just came is still here. And the person who left because we started over for the new person. That's fine. So you saw that let me go back actually, because this is pretty important. So by the time you get to Mars, you've been traveling for 9 months, you're going thousands of miles per hour. And what first starts to slow you down is the atmosphere. And the atmosphere on Mars is actually only 1% as thick as the atmosphere on the Earth. So it's really not much there, but it's enough to start slowing you down. Actually, the atmosphere on Mars is really frustrating because it's thick enough that you have to deal with it, but it's not thick enough that it actually helps you a whole lot. But as you can see, it does still slow down the spacecraft, and it does still create a lot of air resistance that absorbs the kinetic energy of the spacecraft that has been traveling through space for 9 months. So you have a period of deceleration from air resistance, and you can see those little jets firing to keep the spacecraft lined up and traveling towards its landing site. So then you see these little ballast weights that are jettisoned. And then a big parachute deploys. So now you've already decelerated significantly due to air resistance. Then for this phase, at this altitude and air pressure, a parachute makes the most sense. And that was a very large parachute, I believe the largest ever deployed anywhere. And then this ridiculous thing happens. The rest of the system drops out, and retro-rockets start to fire and descend further. So I'm going to pause this. Compared to, oh, I closed the article. Compared to the SpaceX article, and, well, that's not what I meant. I'll just tell you guys about it. Basically, SpaceX, Elon Musk has said that they are not going to use retro-rockets as the primary form of deceleration for the Red Dragon on Mars. And that may not capture all the details exactly, but it was a fairly major announcement from them, moving away from that architecture. And as you can see on this video, I'll resume it again, the retro-rockets are actually only firing during a small amount of the descent. So we've gone through most of the atmosphere already with either nothing, just air resistance, or a parachute, and then the retro-rockets. And as we can see, the retro-rockets actually were looking at the ground. The retro-rockets are only active during a part of the descent and not even all the way down to the ground. So here you can see the rover being lowered on cables, because if the retro-rockets came all the way down, the rover would get really dusty, and the instruments would get all messed up. So retro-rockets really not the ideal way all the way down. Anyone have any questions? Whoever you are, watcher number one. If you type them out in the stream, I'd be happy to, in the live chat rather, I'd be happy to answer them. So I'm going to switch this off. Let me just go back to me. So that is some of the differences between what SpaceX is talking about and what has happened in the past. And can't wait to see what SpaceX has in mind next. Now, since for you, that one person who's there, I'm going to show you something cool if it works. Let's see here. Add. We're going to go into something called Eyes on the Solar System. And assuming it works, it will just take me a minute. Select window. No, that's not it. If you are still there, yep. Let's try this again. I'm using this streaming software called Game Show, which is typically used for, here we go, select window. Window, no. Application, there we go. So, let's see if it puts it there. We are going to, oh wait, there we go. I'll get the hang of this. So, we are going to move over to this program called Eyes on the Solar System, and we are going to look at some cool stuff. Let's see what happens. So Eyes on the Solar System is really a full solar system simulator that you can use to look at planets and spacecraft across the solar system in real time, looking at things where they are now. You can go all the way back decades, forward decades. And so, assuming this works decently, all right, so it's chugging along, but that's all right. So let's take a look at Mars, since that's what we've been talking about. Maybe my computer needs more RAM. You can see why people buy ridiculously powerful computers to do this. This is not even that demanding on the computer, but streaming it in, what is this, 720p seems to be pretty tough on my computer. But anyway, if this goes well, maybe I can upgrade it. So here we are looking at Mars, and so we can see a number of interesting things here. Try to focus just on Mars. Mars is actually a pretty busy place right now. There's 2 active rovers and multiple orbiters. So Mars itself has 2 moons, Phobos and Deimos. They're really small. I see someone is still here, so I hope you're enjoying this, because I'm enjoying talking about it. All right. So clearly, all right. So here's Phobos. So both the moons of Mars are little potato-shaped things, probably captured asteroids from the asteroid belt, and they're actually getting closer to Mars every year. So in about 10 million years, if anyone's living on Mars, they're in for quite a show. As I think it's Phobos is the closer one. Hits the atmosphere, and that would be quite a show. So I don't think any of us are going to be alive for that, but maybe somebody will be. So we were talking about Mars in general. Let's go back out to Mars. Actually, let's look at Mars Odyssey just for fun. So Mars currently has 2 communication satellites orbiting, and I believe 2. Okay, that's interesting. Double-clicking isn't working on this while I'm streaming. So there's at least 4 spacecraft orbiting Mars right now. There's Mars Odyssey, which is a communication satellite. You can see here solar panels facing the sun, radio dish facing the ground. Let's see, we're going to zoom back out to Mars. So, by the way, anybody can use this program, Eyes in the Solar System. It's really fun, really useful to educate yourself, and kids love it. So here's another thing orbiting Mars, the Trace Gas Orbiter. One more time. Trying again. There we go. Downloading. Interesting, because I'm streaming. The downloading is going very slowly. Okay. You know, I could do videos that are not live. They would be a lot more work, but they might be a little more polished. I don't know. I might do that. Kind of thinking of doing like a video on every single space mission ever, which would be a pretty big commitment, but also would be pretty fun and maybe interesting, hopefully interesting. So you can see a couple of things here, actually. That's kind of interesting. When you think about orbiting another planet, there's a lot of details. Different types of missions need to be different altitudes. So something like this, the Trace Gas Orbiter, at this point in its orbit, it's pretty far away from Mars. And that does certain things. That gives it a view of more of the surface of Mars for its instruments. You can see the pole, one of the poles of Mars from here. There's all kinds of reasons why you want to be farther from the planet, but typically orbits around other planets are elliptical, meaning some parts are closer to the surface than others. So let's look at Mars Express. Again, there we go. So Mars Express here currently, right now, is over the pole, one of the poles. So that's fun. So you can really look at any of the planets in the solar system and see what's going on at them at any time. Oops, let's go back to this. So when I go in person, I like to go through the entire solar system, planet by planet, talking about different missions. Maybe I'll do a video version of that, but probably just record it and not stream it, so it'd be smoother. But I think we're going to wrap up the stream here. But I really enjoyed doing this. Thank you for watching, you mysterious one person who may have stayed this entire time. I appreciate that. I think I will do this again, and maybe do some more homework next time. But I hope you and that other person who was here briefly, and whoever else may watch this in the future, learned a little bit about the planets, and maybe even got excited about them, particularly Mars and the current events that are happening now. Let's see. Oh, where'd I go? Well, I wiped out my own. I wiped out my own video, so I'm going to try to do that again. Here we go. Okay, I do know kind of know what I'm doing here. The next stream will be a bit more professional. But anyway, that is the first stream of Space Talk. I hope you enjoyed it. I sure did. And follow the channel, subscribe, and I will. I'm sure I will do this again.